Hello, everybody. I'm back. It's Thursday nights. Is it again? Once a time. Well, how did that come out? All right, let's try again. I'm back, everybody. And once again, it's Minutes with Milo time. And I am live on the internet. Thank you very much for tuning in. If you're not tuning in, I thank you very much for watching. If you're not watching, then I don't thank you very much. How can I? You're not even here. You got to be tuned in for me to say thank you for watching live or when it's recorded. Excuse me. But anyway, thanks for coming by the channel, scoping it out, listening. Leave me a comment, subscribe. Been in the bottle cap. Something you do, right? It's just one of those things you do, like popping your knuckles. It's just one of those things that you do. Tonight's show, I have made some. Okay. I have attempted to make, and we will find out if it still is the way I think it was. I know it was because I tested it. But when you test things and then you put them into action, sometimes they're not the same. Sometimes it just doesn't play out like it did when you were tested. But I'm pretty sure this will. Last week, I did a show, special guest, GROK3, asking a few questions. Had a very silly voice, that I used with Firefox as an extension. It sounded very cheap, computerized AI-ish. That's a word, I'm sure. So I found on this computer that I'm working with that it does have Edge. I mentioned that last week. So I started it, updated it, went through these things. It wouldn't load the page. It just gave me a black screen. But I persevered. I didn't stop. I wouldn't let go. I was bulldogish. And so now I have GROK3 on Edge, and we are listening to a much better voice. It is Microsoft Ava Online Natural English. Mwah. Piece de resistance. Now, I talked about that last week. Was you can change voices. It's got a slew of voices. You can make Ava with a Russian accent, speaking English, speaking Russian with an English accent. I don't know, all kinds of stuff. But the one that I like the best is the one we've got now. And I don't think it's really the default, but you can put it in there. It highlights the words, the sentences. It does a much better job. I wish that I could have figured it out last week. But last week wasn't bad to show what AI could potentially sound like. Back in the late 70s sci-fi, the choppy, computerized, synthesized voices that, that's the way they were. And then apparently, in some of the silly extensions you put into Firefox, that's the same way it is right now, which is hard to believe. So anyway, the other side of what tonight's show is going to be about, I put in there DNA and stem cells because I've listened to lots of podcasts. You know that. And one of the podcasts I was listening to talked about things like Neanderthal DNA and what happens to DNA if you send it off to a place like 23andMe. Where does your, they I know I'm doing it again. They sample it, or you send them a sample. They test it. They send you back the test results, but it's stored on their servers somewhere. And I haven't looked at it because I've never done that. I mean, why? Look at me. Look at any of us. We could be like, dozens of things put together. Most of us, are. Thrown together, stirred in a bowl, throw in the oven, cooked it, and there it is. So why bother? I mean, I'm not trying to win a contest. I'm not going to try to join the club. What difference does it make? But if I did, where would that DNA go? Where would that test result go? So we don't go that in depth. We look at it just a little bit. I've done a couple of these little searches, and we'll put GROK to the test a little bit tonight. Let it read some stuff. Let her read some stuff, and we'll look at where it goes to get its information. We didn't do that last time. Talked about it, but we didn't do it. I also heard a thing on stem cells on another podcast, and we'll look at that. Thought that was pretty interesting because the spin that they put on it is nothing that I would have thought. And I always wondered exactly. I kind of have a rough idea of what stem cells are and do or could do. Oh, we'll look at that too. But anyway, let me get the new and improved GROK3 going on. And let's see. I'm going to clear this out. Oh, we chat. Okay. Alrighty. Wow, dude, what is that? Alright, that's more like it. I'm sure in this nice OBS studio, there's a way, I know, but you have to pick these things out. Tell it where to look, watch a show, and then you can do stuff like that. Okay, so good evening, a minute with Milo. How can I help you today? That's not the way it says. Let's see if we can get it to read that to us.
Developments.
Nope. What was that?
On March 4th,
No, stop that.
Good evening.
There we go.
Good evening, Minutes with Milo. How can I help you today? What do you want to know? Deep search. Think. GROK3. Research. How to. Analyze. Create images. Code. Switch to personas. Explore the entire.
Much better voice. Just reading that, a nice, pleasant female voice. It's not chopped up for the most part. It's fluid. It's normal. See how it highlighted the words and the sentences and all that stuff? Much, much better. And what I like, I mean, I'm not crazy about all Microsoft products by no means, but this part I like about Edge. Anything else, I'm not real sure. This part I like. The native voices, I didn't have to download any kind of extension. You can hit, I think it's Control-Shift-U, and it brings up the read aloud. You can't see it here. It brings up the read aloud bar at the top. And I like it. So that's my tip. You want decent reading, text to speech, reading web pages and stuff. Try using Edge and the read aloud function. I think it's built right into it. Nothing really special to do. Control-Shift-U brings it up. So, first thing I wanted to kind of jump onto was I want to know exactly what a stem cell is or does, and that will kind of clear my mind, let me know, you know, when it poses these answers. All right, so really quick, I think I'm going to have to shrink it down here if I can. This is one thing I'm not 100% sure about, how this may play out. A little more. Down to 90%. Let's go to 80. All right. So let's see if she'll play this.
Entire universe.
No, start up here.
What are stem cells?
There we go.
Stem cells are unique cells in the body that have the remarkable ability to develop into many different cell types. They serve as a sort of internal repair system, dividing essentially without limit to replenish other cells as needed. There are two main types of stem cells. Embryonic stem cells. These come from early-stage embryos and can turn into any cell type in the body. They're pluripotent. They're widely studied for their potential in research and medicine. Adult stem cells, found in tissues like bone marrow or fat, these are more limited, multipotent, typically regenerating cells specific to their tissue of origin, like blood cells or skin cells. Stem cells are a big deal in science because they could help treat diseases by replacing damaged cells. Think regrowing heart tissue after a heart attack or repairing spinal cord injuries. There's also buzz about using them for personalized medicine, though challenges like ethics, immune rejection, and controlling their growth to avoid tumors are still being worked out. Does that cover what you were curious about, or did you have a specific angle in mind?
Hey,
How can
Robert.
GROK help?
Oh,
Deep search.
There we go. Welcome to the chat. No, I don't know what Peyton Manning had, done, but I knew a guy that had knee problems, and he was thinking about doing the stem cell therapy. I don't even know how that works. Okay, neck surgery. Did it work? Do you know if it, helped him? If it worked out? I believe when my kids were born, you had an option of taking stem cells. Oh, so it was very successful. Well, that's cool. How long ago was that? Do you know? You had it done? Maybe he's typing. Robert's typing. Like that. Anyway, I think when my kids were born, we had the option of taking stem cells. I think it was in the umbilical cord and freezing that, and I don't know how that was, to save stem cells so that, like, later in life, if they had some kind of disease or problem, potentially they could use those stem cells, embryonic stem cells, to treat it. So it was back when he was actually playing football. 2011. Well, that's kind of interesting because, I mean, that was several years back now, which, I don't know how early that was into stem cell therapy, but, that's promising that if it worked that well back then, that, surely they've made, bigger and better improvements since then. So I don't know exactly how that works, but we'll look at that. And I'm, so it says adult stem cells found in tissues like bone marrow or fat, and they're more limited, typically regenerating cells specific to the tissue of origin, like blood cells or skin cells. So I'm wondering, like in Peyton Manning's therapy, did they take cells from his neck? That part of it, I'm just not sure. Found in tissues like bone marrow or fat, these are more limited, typically regenerating cells specific to their tissue of origin, like blood cells or skin cells. So you think they took bone marrow, tweaked it, and made it like neck cells, neck cells, you know what I mean? Like that's a finger, and in there are finger cells. You can't take a finger cell and make an ear out of it, I wouldn't think. You know what? The DNA says this is an ear. When they reproduce and they grow and they expand, I don't have a finger sticking out of my ear. So, in my limited mind, maybe that's what it means by regenerating cells specific to the tissue of origin. Fat cells. So, fatty neck cells. He took fatty neck cells and made it. Because it talks about, trying to limit their growth down here, limit their growth to avoid tumors. They're still being worked out. I mean, that's what scares me with a lot of this kind of stuff is, do you want to be that person? 3 out of the 5 rats didn't develop any big tumors on their necks at all. Do you really want to be that person? It's like, I guess it depends on how bad, your how bad it was. But on my podcast that I was listening to, it was on the All In podcast. They were talking about stem cells, using them, specifically manipulating them and creating them from other cells in the body to do certain things. So that was one of the angles I was going to try to look at this evening is that even possible to take a cell, turn it into a stem cell, and then make that stem cell into something totally different. So if you wanted to go from a finger to an ear, could you take a finger cell, turn it into a stem cell that then would go to an ear? I guess is kind of the way I see it in my brain. But we'll laugh. So one of the things I didn't look at here. Where did it go? It didn't show where it got its answers from on this particular. Am I just missing it? All right. So I'm signed into it. Now what I want to do is I want to go back and look at see in my history. Basics and potential current. Okay, see, it gives me a little thing right here. It says current. This is one that I did earlier. All right, and let's see what she says. So here was my question. Let's see if she'll read my question.
What is the latest on turning skin cells into stem cells? For posts, 20 web pages. As of March 20th, 2025, The field of turning skin cells into stem cells or related cell types has seen significant advancements, with research focusing on both traditional induced pluripotent stem cell (iPSC) methods and newer, more direct conversion techniques. Here's the latest based on current developments. Traditional iPSC reprogramming. The process of converting skin cells into induced pluripotent stem cells, iPSCs, was pioneered by Shinya Yamanaka in 2006, earning.
All right, so in the podcast I was listening to, they talk about the Yamanaka factor, and that I didn't know what that was at the time, but that's what she's talking about right here. The Yamanaka, I can't remember how she said it, in 2016, or 2006.
Earning him a Nobel Prize in 2012. This method involves introducing specific genes, typically 4 transcription factors, October 4th, SOX2, KLF4, and CMYC, known as Yamanaka factors, into skin cells to revert them to a pluripotent state, capable of becoming almost any cell type in the body. By 2025, this technique has been refined but remains a cornerstone of stem cell research. Recent efforts have focused on improving safety and efficiency, as the original method uses viruses that can integrate into the genome, posing risks like mutations or cancer. For instance, earlier breakthroughs, circa 2018, from researchers at the University of Helsinki and Karolinska Institutet demonstrated that skin cells could be reprogrammed into iPSCs by activating their own genes using CRISPR technology, avoiding the need for external gene insertion. This approach, which targets endogenous Yamanaka factors, has continued to evolve, offering a more physiological reprogramming method. While not explicitly detailed in 2025 updates, this line of research has likely progressed, with ongoing efforts to make iPSCs more clinically viable by reducing genetic risks and enhancing the similarity to embryonic stem cells.
All right. So this last part that she was talking about is what they talked about on that podcast, and their line of thinking in this particular conversation was about intro IVF reproduction, where you take egg cells and sperm, and you inject them, mate them, whatever you want to say, fertilize them outside the body, and then you try to get intravitro fertilization. And they were talking about that, how hard it is that a woman has X number of eggs throughout her lifetime. And as she gets older, they degrade. So when they go in to try to do this to help, fertility, apparently it's an invasive process to extract the eggs from the female and then, fertilize them outside the body and then insert them into the female again for growth. So what they were talking about in this podcast, potentially with this information, this, way of doing things, you could take skin cells. I made fun of, a finger cell, but you could take a skin cell off almost any part of her body using these Yamanaka factors in this process, convert that to a stem cell, and then convert that to a viable egg, and then use that to do introvert, how do you ever say it? The inter vitro fertilization. That's the way I'm going to say it. It's wrong, but I think that's what I'm going to say. IVF. So that's what they were talking about. This in a very narrow window. Excuse me, because these people that were on the podcast had gone through IVS to try to have kids, overcoming, some problems that they were having on naturally conceiving children. And I thought it just blew my mind, you know, that they could do that, or even trying to do that. I mean, that seems like that's a bigger step than taking a skin cell, turning it into a stem cell, and then using that to treat, you know, a torn meniscus or a rotator cuff, or the neck injury, or whatever it might be that's damaged or malfunctioning in your body. Or maybe they can treat kidney disease or liver disease or cancer with it. I don't know, but it just seems you know science fiction that they could take you know a cell from your body and through some processes turn it into something that can then repair other parts of your body. I mean, it just seems, or make children. Seems crazy. So let's see what it says. Let's go on and read the rest.
Cells. Direct conversion breakthroughs. A major shift in 2025 comes from MIT researchers who have developed a method to bypass the iPSC stage entirely, converting skin cells directly into functional neurons. Reported on March 13, 2025, this technique uses a combination of three transcription factors, NGN2, ICEL1, and LHX3, delivered via a modified virus alongside genes P53DD and mutated HRS that boost cell division before conversion. In mouse models, this method achieves over 1000% efficiency, producing more than 10 neurons per skin cell, compared to the traditional iPSC route, which is slower and less efficient, often taking weeks and yielding fewer mature cells. When transplanted into mouse brains, these neurons integrated with host tissue, suggesting potential for treating conditions like spinal cord injuries or ALS. However, in human cells, the efficiency drops to 10 to 30%, indicating that while promising, the technique needs further optimization for clinical use. This direct conversion skips the pluripotent stage, reducing the risk of tumor formation, a concern with iPSCs, and cutting the timeline significantly, which could accelerate therapeutic applications.
So I don't know if that really adds more or less to it or not. I mean, I don't understand some of that. It seems like, one of the things they mentioned before is using a virus to cause the change in the cell was iffy. And it was better to do it a different way. So I don't know. But, back to the fact that they could, still that's a potential doing it, whether it's one way or the other, seems kind of just really mind-boggling to me. And see, this part of the GROK was interesting. She reads it a lot better. It makes more sense. Still kind of choppy. I think some of that where it hesitates for a second or two is the computer issue. But one of the things I wanted to look at was this. I've never looked at these. Let's see what this looks like. So it brings it up over here on the side. Let's see this one. You can see here. Human skin cells converted into embryonic stem cells. First time human stem cells have been produced via nuclear transfer. Scientific Daily. So if we look at that, we can tell it to open that in a new tab. So this is the web page that she was referencing. I'm going to call her she because that's the voice, the way it is now. that she was referencing in the answer. One of them. How did I get it down and it still doesn't fit? So this is a Scientific Daily article. And so this is May 15th, 2023. So over here on the side is where they list the websites, and you can click on those and follow the links. Let's see, and here are the posts. You can't see them. Once again, they're cut off to the side. You can follow these links to X posts or entries, however you want to say it, and you can read them directly and come up with your own conclusions. So, that's pretty interesting. Let me do one other thing. I thought about this. So I'm going to copy my question. All right, let me, I hate to use Edge, but this is what I've got it focused on right now. So let's do this. I think this is going to use Microsoft Bing. And let's just do a search, okay, on the same question. Okay, so that's an interesting article. It says without converting them to stem cells first, MIT engineers turn skin cells directly into neurons, and that was what they talked about down here in the bottom. Where was it? Right here, implications and challenges. Right here, she talked about it.
Such as generating heart muscle cells for cardiac conditions or blood stem cells for blood diseases. The MIT direct neuron method, meanwhile, could streamline regenerative medicine for neurological disorders, avoiding the intermediate stem cell step that often leaves cells stuck in immature states.
So she does reference that article that I looked for directly and got it here, or I looked for and it gave it to me, you know what I'm saying, in a different, same information, different direction. But, GROK3 takes it and puts it into basically like an article, you know what I mean? An article that you would read, for a website, and she generates this thing on the fly, which is, very interesting. And then you can click on the specific article you want to see that they used or she used to make that, to, put it all together. So one of the other things I looked at, not really in the same area, but in the same vein, I guess, biology, is DNA. And what I asked, history, was, I don't know, I would never do it. Like I said before, I have no interest in knowing. Do I need to know? But there are places out there that will test you and then tell you how much German or how much Irish or how much Swedish or whatever percent supposedly through DNA. And they can also tell you what percentage you have of Neanderthal DNA. Okay. So I thought that was interesting. How much, is there? How much, Neanderthal DNA might be there? So I asked it, and I don't know how to spell Neanderthal, and I mutilated it, but it figured it out. So let's see what she says. Oops, sorry.
Neanderthal genes has become increasingly accessible thanks to advanced
Oh, I'm sorry. I can't wait.
testing for Neanderthal
There we
genes
go.
has become increasingly accessible thanks to advancements in genetic research and consumer DNA testing services. Here's what I can tell you about it. Neanderthals were an extinct group of archaic humans who lived approximately 400,000 to 40,000 years ago. Modern humans.
All right. So, just as a side note observation, that's like saying I'm somewhere between 40 and 40,000 years old. I mean, they lived approximately 400,000 to 40,000 years ago. I don't, why such a big window? I have no idea why there is such a big window. We're extinct or are extinct. We're extinct or are extinct. We're extinct or are extinct. Neanderthals were an extinct group. Okay. I'm piecing this together. I'm following you. She should say Neanderthals are an extinct group of archaic humans. If they were extinct, maybe that's a slip, Robert. Maybe she knows that somebody has brought back Neanderthals and cloned them, and now somewhere on Earth there is a group of Neanderthals on an island somewhere out in the middle of the ocean, you know, and they're going to open a zoo, and we're going to be able to go out there and observe them in their natural habitat. Kind of like Jurassic Park. You think Elon and Trump have set this up, that they've got a bunch of Neanderthals out on an island somewhere, watching them, observing them, getting ready to turn them loose on the world? Maybe they're going to make Neanderthal soldiers. In case they're just kidding, in case they're listening. Well, you never know. So, maybe Neanderthals are no longer extinct. GROK has said it. Neanderthals were an extinct group of archaic humans who lived. Still don't know when they lived, but maybe that they're coming back, making a rebound.
Humans, Homo sapiens, interbred with Neanderthals during periods of overlap, particularly in Europe and parts of Asia. As a result, people of non-African descent typically carry about 1 to 2% Neanderthal DNA in their genomes, while African populations have little to none due to less historical contact.
So 1 to 2%. And I think down here when I read down in here, this says in higher than 1 to 2%, might be 3 to 4%, which is very rare, or in rare cases. So, in an overall picture, how big of an effect could that have? I don't know. Not a lot. It's not. Maybe we'll ask it compared to other. Let's let it read on.
Contact. How testing works. DNA sampling. Companies like 23andMe, Ancestry DNA, or specialized genetic research labs analyze your DNA, usually from a saliva sample. Genotyping or sequencing. They use techniques like genotyping, looking at specific markers, or whole genome sequencing to identify Neanderthal variants. These variants are specific SNPs, single nucleotide polymorphisms, that differ from the Homo sapiens baseline and match Neanderthal reference genomes, such as those reconstructed from fossils, e.g., the Altai Neanderthal.
So they're getting their test Neanderthal DNA that they test for, they're getting the referencing from fossils. So who knows if they've even got that part of it right. I mean, you find a fossil, you try to extract some DNA from it, you're never going to get pristine DNA, right? I don't know about the Denisovan species. You talk about this Altai Neanderthal compared to the Denisovanian species. I don't know. Let's see what she says later on here. Maybe she mentions
Neanderthal. Comparison. Your DNA is compared to a Neanderthal reference genome. Algorithms estimate how much of your genome aligns with Neanderthal-specific markers. Results. You get a percentage or breakdown of Neanderthal ancestry, sometimes with details about traits potentially influenced by those genes, e.g., hair thickness, skin pigmentation, or immune system responses. What you might learn. Percentage of Neanderthal DNA. Most people of European or Asian descent have 1 to 2%, though it can go slightly higher, up to 3 to 4% in rare cases. Specific traits. Some tests link Neanderthal genes to traits like a higher risk of certain diseases, e.g., type 2 diabetes, immune system advantages, or even behavioral tendencies, e.g., being a night owl. These connections are based on ongoing research and aren't always definitive. Regional variation.
So how would they know if a Neanderthal were night owls? I mean, to me, that's what it's saying right there, right? That specific traits, these connections are based on, let's see, regional variations. Where was it? Night owl. Yeah, okay, I'm sorry. I lost my place. Specific traits. Some tests link Neanderthal genes to traits like a higher risk of certain diseases. I don't know. I think they can tell that from DNA. Immune system advantages or even behavioral tendencies. Being a night owl. Is that really, written in your DNA? How would that be? And if it was, how would they ever discover that? I mean, how do they look at that and go, that's the gene for being a night owl? I don't know. That blows my mind.
Variation. The amount of Neanderthal DNA can vary depending on your ancestry. East Asians tend to have slightly more than Europeans, for example. Limitations. Accuracy. Consumer tests aren't 100% precise. They rely on reference databases and statistical models, which can evolve as more Neanderthal genomes are sequenced.
So statistical models, and as they evolve, as more Neanderthal genomes are sequenced. So they don't have the whole Neanderthal genome sequenced out. They probably don't have a full sample, I would guess. I don't know. I mean, like I said, do you get a, you have some tissue, or a little bit of bone marrow, or something from a fossil, or a skull, or a tooth, or something like that. Seems like part of that starts out in having a really good DNA sample, you know, like something frozen in the tundra, like these woolly mammoths where they cut them open and they can eat steak from them. Let's see how to get tested. Blah 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 blah. So one of the things I had heard about these tests was that 23andMe and some of these other ones were making money on the backside by selling these DNA tests or results to China or third parties. So this basically, let's jump down here. It has not been confirmed. Let's see if we can start it there.
No mainstream news outlet has provided concrete evidence that China has purchased DNA databases from companies like 23andMe or Ancestry DNA. Claims on X and elsewhere about such sales, e.g., Ancestry.com selling to the CCP, lack substantiation and appear to stem from rumors or misinterpretations. The focus has been more on potential risks, hacking, corporate acquisitions, or indirect data harvesting, e.g., via COVID-19 testing labs donated by China, rather than verified transactions. Why it's in the news.
So there's nothing been concrete that they have sold it, but that's still another avenue, to me, a pretty good avenue for them to make money on the backside. They get it from the customer. You sign an agreement, I'm sure, uh, nobody reads, no lawyer reads to tell you what specifically it says they can do with your DNA results. And then, on the flip side, they sell that, not necessarily this is, Robert's DNA or Milo's DNA or anything like that. It's just, here's a group of, DNA results. Give me some money for them. To me, that's very, very plausible. And why would that be a problem? Information's king, you know. If you've got the test results, even though you may not have the actual saliva samples or hair samples or whatever, I mean, you've got those results, you've got it mapped out. So if you're trying to figure something out that would, cause great sickness in certain populations, then you need, their DNA sequence to know what would affect them and not affect other people. So that's where I think the conspiracy theory comes in. Is it makes sense that you'd want to sell whatever you could to make more money for your company, and why not sell it to somebody that would like, oh yeah, give me your 2 million DNA test results, and I'll give you $1 a piece for them, $2 a piece. I don't know. Just something I had heard, seen it go across one of the news feeds that, oh, China's buying up everybody's DNA samples. Yep. So your question, let's get down here. What was your question before? Okay. What was that? I want to then DENISO SOVVIA. And what did she call them? Uh-oh, did I miss it? Did I tear it up? Where'd it go? Up higher? There it is. This. See what they say. Difference between what you asked about and the other Neanderthal. Wow. Oh. Let's read the conclusion here.
Shared context. Both groups coexisted in Denisova Cave at different times, and a hybrid, Deni, a first-generation Denisovan Neanderthal mix, identified in 2018, shows they interbred. This suggests overlap in Siberia around 100,000 plus years ago. Their common ancestor diverged from modern humans about 600,000 years ago, and they later mingled with us, shaping our genetic diversity. In short, Denisovans are the mysterious Asian cousins with a patchy fossil record, while Altai Neanderthals are a well-studied eastern branch of the familiar Neanderthal family. Want to dive deeper into their DNA or fossils? How can GROK help? Deep search.
So, all right. So they were separate. They interbred. Their time in Siberia overlapped. Don't say for how long. But something I found interesting, yeah, the plus threw her off. She read the 600,000 years ago perfectly. But the 100,000 plus years, yep, the plus sign, I think you're right, screwed her up. 100,000 plus years, which was interesting. So let's go back to the top. And start reading here.
There hasn't been any definitive, credible news as of March 20th, 2025, confirming that China has directly purchased.
Go back. Where did I ask this other question? There we go. Went too far.
Denisovans and Altai Neanderthals are two distinct groups of archaic humans whose genetic and physical differences reflect their unique evolutionary paths and environments. Both interbred with modern humans, Homo sapiens, leaving traces in our DNA, but they differ in geography, fossils, and genetic profiles. Here's a breakdown. Denisovans. Discovery. Identified from a finger bone, teeth, and a jawbone found in Denisova Cave in Siberia, Russia, starting in 2010. Genetic analysis revealed they were a distinct group named after the cave. Time period. Lived roughly 200,000 to 50,000 years ago, overlapping with Neanderthals and early modern humans. Geography. Likely widespread across Asia. Evidence, genetic and fossil, points to Siberia, with a jawbone from the Tibetan Plateau, China, suggesting high-altitude adaptation. Their DNA is most prevalent in modern populations of East Asia, Southeast Asia, and Oceania, e.g., up to 3 to 5% in Papuans and Aboriginal Australians. Physical traits. Sparse fossils limit our knowledge, but the Tibetan jawbone suggests a robust structure. Teeth are larger than those of Neanderthals or modern humans, hinting at a unique morphology. Genetic studies suggest adaptations to diverse climates, like high altitudes, e.g., the EPS1 gene for oxygen efficiency in Tibetans. Genetic legacy. Denisovan DNA is less common globally than Neanderthal DNA, but shows up strongly in specific populations. It's linked to traits like immune system enhancements and fat metabolism suited for cold or high-altitude environments.
Yeah, Aborigines, when they were talking about high altitude metabolisms and enhancements. I don't think Aborigines, Australia is not high altitude. Let's see, I'd like to see a picture. Let's see what that'll do for us. Paste. Wonder what we're looking at here. Now let's just start with one, not and. So I want to get a idea of which one they think is which. So here's a question that I have. If you look at some of these faces, you can almost say, well, you know, these are people that live down the street. You know what I mean? Maybe not this guy, but this kid here, you know, or this girl here, you know, you see those kind of physical traits now, but yet they say, you know, genetically, it's only, you know, 1 to 3% of their genes, you know, in modern humans. So, seems like that's, you know, a pretty good showing for only 1 to 3%. See, this guy here, he could be the lead drummer in a rock band. Lead drummer. Well, maybe they have 2 drummers. I mean, he could be the drummer, right? I mean, he doesn't look like that much different than a long-haired, you know, person from today. I don't know. So I still don't understand why there's such a jump in 200,000 to 50,000 years. I mean, you know, that's a space of 150,000 years. That seems like that's awful, an awful big window. I don't know. But I had often heard, you know, that people were, you know, doing testing to see, you know, how much Irish and how much German and how much all this, you know, their history and that ancestry. And then I started hearing, you know, well, they can tell how much of your DNA is Neanderthal, which kind of blew my mind. Was, well, how do they, first off, how do they know what, you know, Neanderthal's DNA is, and you know, that kind of stuff. So I guess now we're learning, or I'm learning. Maybe Robert already knew all the answers. He's secret special like that. So anyway, did some more work with GROK3. She's much better voice, much better reading. Like I said, my suggestion is you want to get into that, doing it like this, find you a browser like Edge that has some really good voices. She's not 100% perfect, but like I said, I think some of the sticking points is probably, you know, my processor, my computer uh, causing it to stumble. And then, you know, if you're really interested, you can go to the reference pages, look them up, read the articles yourselves, and get that. So one of the things that I might do later, this is almost an hour now, is that when I very first started working and messing with this, I asked, you know, Grok a couple of different questions, 2 sides of the same coin, and then I asked it to give me a newspaper article, write me a newspaper article that supported one side, and then write me another one that supported the second side, and make them 200 words or less. And it crashed my computer. It never did process, and I don't know if that was, you know, my problem, GROK's problem, whatever it was. It never threw an error. It never did anything. It just kind of froze. I got tired of waiting for it to do anything. So I went on, changed did something else on the computer, and then walked away. And when I came back, the page was closed or blank, and it just never did work. I would like to get it to write something like that, using the information that it finds to see if you could, I'm sure there's going to be lots of people out there that, do some work like this, get some responses, pull 3 or 4 things together. Like, as long as I don't start a new chat, all these questions, you can ask it or ask her to go back and say, oh yeah, well, in my first question, you responded to, 400,000 to 40,000 years ago. Now you're saying, 50,000 to 100,000 years ago. Why the difference? What's the discrepancy? And she'll go back and look at the other question and tell you, well, when I was referencing this at that point, now I'm referencing these individuals, and so that's maybe why the, discrepancy is. So you can get it to go back and look at older questions, older information that it's found, compare it to what it's telling you now, and give you the difference and why it's different. So anyway, that would make interesting, a newspaper article. And there's probably people out there that are going to do a bunch of research, put a bunch of questions in there, fine tune the data, and then say, write me a newspaper article that tells me this, or another thing, and then maybe even throw some pictures with it and become independent writers. Who knows? It might be, I'm sure it's going to be, and it probably is right now, one of the new jobs being created by AI, because, how long would it take me to research 20 different web pages, some posts on X? If I'm doing it on my own, I'm going to, Reddit, Facebook, all these other things, and then bring it all together, put it in my mind, write it up as a nice little story, and sell it. It's going to take me a long time, even if I've done it a bunch. But with this, you have it do it, go back, look at some of the research, verify what it's telling you. Where did it get the information? Is it legitimate? And then, go from there. So, pretty interesting. All right, so that was another kind of integrated this time, a little bit more maybe, with the show, what GROK was doing, how to do the research, look at some of the interesting questions, and it's kind of like I see it like doing my other shows, where I would type in the questions to Google or to Bing or wherever it was, get information, and pick out the web pages. A lot of times Wikipedia, read it to you, discuss it, hopefully, get some responses from the chat, and if not, just make up my own answers. But the only thing I don't like about GROK, I mean, not the only thing, one of the things I dislike about it is you don't get the images. You don't get to look at the articles and find which ones, really catch your eye and click on it and, read from that. But the good thing is, you get 20 web pages, pertinent information's all brought together, and so you don't have to go to 20 web pages and find it all and then, read it. So anyway, all right, if you've made it this far, I appreciate it. Robert, thanks for coming by. Give us comments. Get on there. Don't be afraid. Of course, I've only used it like 3 or 4 times, so maybe you ought to wait for a month or so before you dive into it, see if they take me off there. take me off the air for, messing around with GROK. But I doubt if they will. They know better. You can't mess with the show, man. So anyway, leave me a comment. Tell your friends, your family, like, subscribe to the channel, turn the notifications on, and come on back and see me Thursdays at 9. Probably will not take back up the Monday night show just because there's so much going on. Monday nights, I just need the time to get some of these projects done. But anyway, let me know if there's topics that you want to talk about. And as always, you can call in, become, part of the show. We can get you on the air, all that stuff. See you later, Robert. Thanks again. All right, everybody. That's it. Got any questions? Send them to me. And let me find my stop streaming button. There.